Hello everyone and welcome to very first lesson of this Cisco ACI training series. I am really excited to have you here because over the next few hours we are going to take you from absolute beginner to confidently understanding one of the most powerful data center technologies in the world, Cisco Application Centric Infrastructure or simply ACI. Now, before we dive into ACI itself, let me ask you a quick question. Have you ever wondered why Cisco built ACI at the first place? What problems were they trying to solve? Because you see, traditional networks have been running just fine for decades. So, why do we need something new? By the end of the video, you will have this understanding. We'll cover why traditional VLAN networks struggle in modern data centers, the brilliant spine leaf architecture in ACI, the role of EPIC controller, what we mean by policy driven networking, and finally, the difference between physical and logical topologies in ACI. Let's get started. So, why the traditional data center fabric struggle? For years, data centers were built using what we call three-tier architecture: core, aggregation, and access layer. The design worked beautifully when most traffic was north to south, meaning that traffic flowing from user to the outside into the data center and back out. But here's the thing, modern applications don't behave like that. Today, applications are built using microservices, distributed databases, containers, and these components talk to each other constantly inside the data center. This is what we call east-west traffic, and it now accounts for nearly 80% of the data center traffic. Let me grab a pen and try to explain this. For example, if we talk about traditional network, it was like there would be a core layer, then there would be an aggregation layer, and then there would be access layer switches. These will have VPC connections. These will have port channels like this, like this. This is what we get from the traditional data center network. Now here, the first problem that comes in this kind of network is spanning tree protocol or STP. We all know about spanning tree protocol or STP. In traditional network, STP prevents loop by blocking redundant links, right? So if we have a topology like this, to reach any of the particular node, we have redundant path, correct? So in this case, STP is going to block either one of them, like this or this. So what we are losing is we are losing an entire link capacity, and that is not very scalable. So we wanted to get rid of this particular situation. The second problem with the traditional network is about VLAN scalability. We have very limited 4094 VLAN. In the large multi-tenant cloud environment, that's just not enough. The third problem and very important problem of the traditional network is manual box-to-box configuration. Now let's imagine that you have to deploy an application and you have to do the configurations for that on over 30, 40, 50 switches. Now manually going to each and every switches and type the command is very error prone method, and it is also not very scalable and not even efficient. So ACI solves this particular problem as well. We'll see how all these things work, how ACI is solving all these problems. The fourth and important problem that we have is the weak security. VLANs separate broadcast domain, but they don't really enforce application level segmentation. Once you are inside the VLAN, you can usually talk to everything else. That's a big problem, and ACI solved this problem as well. We will see a lot of micro segmentation related capabilities that you can do at the application level in ACI, which was not present earlier. The last but most important challenge was no centralized policy. Every switch is its own island. There was no brain which can see and understand the whole network, and make policies on the basis of that information. There was nothing like that in traditional network. We'll see how ACI is solving all these problems in next slides. Now before that, we'll see the components of ACI. In ACI, we have APIC controller, we have spine and leaf, and then at the bottom we have the workload sitting. Now, the role of APIC controller, it's a centralized controller. It provides centralized policy, centralized management for ACI and its components, while the actual forwarding or the data plane is sitting on these guys, spine and leaf. So APIC is just having the policy plane, policy and management. It will send the instruction for these guys to get configured. Once the configuration is done, these guys will take care of the control plane and the data plane. So that is what it is written in this particular point. Spine and leaf run protocols like ISIS, BGP, COOP, etc. Those are nothing but control plane protocols and exchange information between them. And also once the control plane is up and running, they will go ahead and program their forwarding tables to forward the actual data in the hardware, and that's how the spine leaf architecture works. Then at this layer, connected to access, if we want to compare it with the traditional network, so these guys are workloads like servers, physical servers, VMware, ESXis, Kubernetes clusters, etc. Now let's see how ACI solves the challenges of the traditional network. So first, as we seen, spine leaf kind of architecture. This is the spine leaf kind of architecture, and let's say one workload is connected here, another workload is connected here, another workload is connected here. In ideal world, they will be having connections with VPC, so it will be like that. But let's say for the discussion sake, they don't have VPC, they are connected like this. Now, in order to reach from one endpoint to another endpoint, for example, this is endpoint 1 or server 1, this is endpoint 2 or server 2. They want to talk to each other, they have some east-west traffic. So in all cases, they will always have the predictable latency. For example, if endpoint 1 wants to talk to endpoint 2, it will go to leaf 1. Then it can either go to spine 1 or spine 2 and then come back to leaf 2, and then it will reach to endpoint 2. So always the latency or always the path is going to be leaf, spine, leaf. So with that you get the predictable latency. The second part is all links are active. So inside this particular fabric, we don't have any layer 2. We have ISIS running between the links. So these links are layer 3 links. They will be divided into sub interfaces and they will be configured with the IP addresses. They will run ISIS in between them. So you can keep all of these links active. The STP is not the only benefit. As you can see that STP tree is not blocking anything here, but STP is not the only benefit. We also have something called ECMP. In routing world, we have this concept called ECMP. What happens is, for one particular next hop, if we have multiple paths, let's say path 1, path 2, path 3, path 4 are there, we can use all these paths to load balance traffic for this particular destination. This is what equal cost multipathing means. Now the third very important benefit of ACI is it provides the horizontal scaling. For example, let's say your business is growing and you want to increase the servers. So for that you just connect leaf here and connect it to spines. That's all. That is all you need to do for the horizontal scaling, and it scales up to 500 switches in one fabric. Then we have something called VXLAN overlay. Now VXLAN overlay provides you 16 million segments. In comparison to VLANs, we used to have 4094 VLANs, but now with VXLAN we get layer 2 encapsulation first of all, and also we get 16 million segments. Now with this encapsulation that we are getting, we get a lot of more capabilities that we are going to discuss in the upcoming videos. But this is from 4096 VLANs to 16 million is a huge benefit. Now, all these benefits that we have seen in point number 1, 2, 3, 4, these are present in different fabric types. For example, if you take example of BGP EVPN type of fabric, that will also provide you, because that is also a class architecture that also is based on spine leaf of type of architecture. So you get a predictable latency there. You get all links active there as well, because in the core we have BGP running. Then it also provides easy horizontal scaling, and also the VXLAN is running in those fabrics. So we get all of these 4 points there. But the most powerful point that ACI provides is powerful automation. Now, this is my personal opinion, but I have not seen better automation platform than Epic Controller. It has a very tight control. It is a tightly coupled architecture between the spine leaf and all the components that we have in ACI. It provides automation of the workloads as well, which are connected with the VMM integrations. Epic Controller provides a great automation tool, and also it's a centralized controller. We are going to see its capabilities in the demo section of this video.